Hello? Okay, that's going to take some getting used to.
Yeah.
Okay, so yeah, my name is Lucian Silcox. I'm currently adjunct faculty in the Department of Computer Science at STC. Applying for a full-time position, we'll see. Yeah, like Homo mentioned, my first time at Code RGB was the first one in April. This is only my third time here, and I knew, I think, by about halfway through the first meeting that I was going to be teaching, so it happens pretty quick if you want to do. So yeah, I'm going to jump right into it because we have a lot of material to cover. I'm going to be looking at Python programming language today. Obviously, I designed this lesson to be to focus on the syntax of Python, and so it kind of presupposes some basic knowledge of programming fundamentals. Right? If you don't have that, if you've never coded before, Python is an incredibly easy language to get started in. It's a great language for beginners. And even if you don't understand all the fundamentals that I'm kind of having to blow through so we can get through this in time, I encourage you just to focus on how simple the syntax is, because if you understand the syntax, you have all the building blocks and you can figure out how to put them all together later. Right? So, okay, jumping into it here. First of all, what is Python? Well, officially we can say that Python is an open source, general purpose, high level, multi-paradigm language. And if that means something to you, great. If it doesn't, don't worry about it. It's not really all that important. Python was a language that was designed with no particular task in mind. Right? It is general purpose. Whatever you want to use Python for, you can probably use Python for. And it has been used extensively by, throughout industry and by independent developers. Google uses Python. If you're into gaming, the MMO RPG EVE Online uses Python. Raspberry Pi uses Python. It's pretty much everywhere these days. It knows not to take itself seriously. It's a fun programming language. Python was not named after a snake. It was named after Monty Python. So why should you use Python instead of another language? Well, first of all, Python, like I said, is very simple. It was designed with readability in mind, with simplicity, with the basic idea that you don't need 20 ways to do something if you have one that works. And so it's a very clean, very simple language to learn. Python is very efficient, both in its ability to handle large amounts of data. Python has gained quite a foothold in being used for scientific computing, but it's also efficient just in your ability to write programs. Source code in Python tends to be significantly shorter than source in other languages. Right? So we can develop very rapidly with Python. Python is a very broad language. The default Python comes with a number of standard libraries for doing string manipulation, internet protocols, operating system interfaces, pretty much anything you need. And there are a huge collection of third-party modules that you can access that give you access to pretty much absolutely anything you could use. Like I mentioned, it's used a lot for scientific computing, and so modules like NumPy and SciPy have been optimized at this point to crunch data like no other. Python is cross-platform, as long as you're not using operating system specific stuff, of course. So it doesn't matter whether you're developing for Mac OS or Linux or Windows, it's everywhere. Mac OS X and Linux actually come with Python installed natively. Windows, you have to install it, but it's not that big of a deal. And tying into our last presentation, if you're into the Internet of Things and believe that everything you see should have a computer shoved inside of it, Python is great for that too. You can program Arduino with Python. Like I mentioned, Raspberry Pi uses Python. So if you're into that concept, Python's a great language there as well. So there are downsides to Python though, and it wouldn't be fair if I didn't give you those. Python is slower than some of the alternatives. Now I say slower than the alternatives because this is going to cut me off if I can go continue. Because Python is not, I cannot get used to this, sorry. So Python is not a slow language, but compared to compiled languages like C++ or Java, it is going to run a lot slower. Python is an interpreted language. It's also a dynamically typed language. And really all that means is that it's doing a whole lot more at runtime, and the more it has to do at runtime, the longer it takes. So it is slower than some alternatives, but unless you're developing something where speed is absolutely mission critical, that's probably not that big of a deal. Additionally, a lot of the modules like NumPy and SciPy have been optimized to do what they do very, very well. And so we don't see some of those speed restrictions quite as well. There are also design restrictions in Python that it is often criticized for. Many languages don't care about whitespace. You can organize your code however you want. Python's not that way. Python actually enforces specific uses of whitespace, which personally, I look at this as a advantage. I teach programming. I have seen the terribly formatted code that some students submit. And so I think anything that increases readability is a pro, not a con, but it does get criticized for that. And kind of the last criticism is that Python is not widely used in mobile computing yet. None of the mobile platforms use Python natively. So maybe we'll see that change in the future, maybe not, but just something to keep in mind. Okay, so once you've decided to use Python, now you have to pick a Python. Because it's open source, there are a ton of different Python distributions out there. We're not going to go into all of them. Today, we're going to be looking at just the standard Python available from python.org. But even when you go to install that, there are two versions of that available. Python 3.x, which is currently 3.4.3, or Python 2.x, which is currently 2.7. The reason for the two different Pythons, Python 3 changed a lot, and so Python 3 is not completely backwards compatible with a lot of the earlier developed systems. So Python 2.7 still exists for legacy purposes, and because 2.7 still exists, there's no rush to upgrade to Python 3, so we just have these two versions of Python that are both perfectly functional, but good for different things, I guess. If you're brand new to coding, I would say go with Python 3. It is a little bit easier for beginners to get into. They did improve a lot of stuff over Python 2, but if you know you need to work with a specific module, then use Python 2.7 if you need to. Personally, I work with Python 2.7 most of the time because of that. Today I'm going to be teaching 3.4 though. Okay, development environment. When you install Python, it comes with a development environment called idle, probably an homage to Eric Idle from Monty Python again. It's simple, it's functional, it's really easy, but it's often criticized as being disposable because you're probably going to want to get rid of it and get something better from Python later. There are a ton of other Python IDEs out there. Again, we're not going to go into them today, we're just going to be looking at idle very briefly. But the Python wiki maintains a long list of different editors, and you can find something that is better suited for you. Real quick, I do want to switch to, not that one, this one. This is the idle IDE, very simple, right? When you first load it here, we're in an interactive Python shell, right? Anything you type in, it's just going to run automatically, right? So if we were to type, which I cannot type apparently when I'm presenting, right? It just runs automatically. If you want to run, write actual Python code that you can save and run later, scripts, all you need to do is file, new file. You can write all your code here, and then whenever you're ready to run it, you can just run it and work that way. So it's very easy to work with. Idle's great for learning kind of how to work with Python before you move on to actual development of something different. And if you want recommendations for IDEs, I can talk to me afterwards. Okay, let's come back to here and get into the actual meat and potatoes of Python coding here. So like I mentioned, Python does enforce certain design restrictions. In Python, we don't have any semicolons or other punctuation indicating the end of a statement. Instead, in Python, the end of a line is the end of a statement. When you press return, that's it. If you need to get around this, you can put a backslash at the end of a line, and that will allow you to continue it on the next line as though you had never actually hit return, right? As in the example here. But for the most part, just keep in mind, end of the line, end of a statement. Blocks of code, working with things like ifs and loops and such, which we'll look at later, blocks of code have to be consistently indented, right? One indent is one block of code. If you have less indentation, it's the end of the block. If you have more indentation, it's a nested block. So you have to have consistent indentation with Python. Comments in Python begin with an octhorpe or pound sign, number sign, hashtag, whatever flavor you prefer. And like most comments, can be placed pretty much anywhere. If you need multi-line comments, we can do that with a document string. Just wrap it in triple single quotes, and then you can do multi-line comments if needed. Excuse me. Okay, so you're in Python. First thing you may want to do, output is kind of the place to start, right? Hello world is the default program. In Python, hello world is as simple as a single statement. In Python 3, it's the print function, and we give it a single parameter in this case, which is just the string literal hello world. Okay. String literals in Python can be wrapped in single quotes, double quotes, or if you need a multi-line string literal, triple single quotes. They are handled all the same. It is completely identical. Python doesn't care what you use as long as the leading one and the trailing one match, right? This is really convenient because if you need an apostrophe in your string literal, just wrap it in double quotes and then use the apostrophe. If you need to actually quote something and have it in double quotes in your string, then just wrap it in single quotes instead and use the double quotes inside. Okay? And it's just going to work. So it gives you a lot of flexibility in what you can do, and it's all treated the same. You'll notice in my examples, I kind of alternate back and forth between double and single, depending whatever it felt like at the time. The print function is not limited to only a single parameter. We can give it as many parameters as we want, and that can be any combination of literals, variables, expressions, pretty much you name it, we can put it in there and print it out, right? So in the second example, I have 5 different parameters, hello, world, 10, 20, and then a variable name, which we haven't talked about yet. The commas, when we're listing them in the print function, commas are kind of an implied space, right? So I have no trailing space after hello, no leading space before world, but this will still print out with the space in between hello and world, right? So the comma is kind of an implied space. By default, print statements always have a new line at the end of them, right? No endels or anything like that if you're familiar with other languages. If you don't want the new line, we can prevent it with the syntax in the top example here. Just include end equals and then just some empty quotes, and that'll get rid of the new line. Anything you put in between those quotes is going to appear at the end of the line, right? Or where the end of the line would be. So if you want, random punctuation or something like that, you can't do that. But typically, what we see most is just empty quotes to signify just no end line. If you want an end line, either by itself or in the middle of a longer string, we can use \n, right? Which is pretty standard. If you're familiar with programming, you're probably familiar with that. And one of the neat things we can do with Python is that Python supports string multiplication. So if we need to repeat something many, many times, all we have to do is print out whatever we want to print times however many times we want to print it. And so the bottom example here, new line times 5, that's going to go ahead and print 5 new lines in a single statement. Right? So string multiplication is kind of fun. There's a lot of other formatting stuff you can do with print that I'm not going into right now for lack of time, but pretty much any output formatting you want, you can do with the print function here. Okay, so print statements are fun for all about 3 seconds until you compile or run your first program, and then you're done and you want to move on to something else. So storing data now. Python makes this ridiculously simple. A variable in Python can store pretty much anything we want it to store, and unlike many other languages, we don't have to declare a variable before we use it. We do not have to give it a defined type. Right? In Python, the variable is created the first time that we assign a value to it, and it will automatically determine what type it needs to be. Right? So Python statements here, we have message equals hello world, x equals 15, y equals 7.5. These are all valid statements. They're all storing different types of data, but Python will figure that out for us. Variable names in Python do have to start with a letter. After the letter, they can contain any combination of letters, numbers, or underscores. Okay, so in Python, we do have these data types. Python is still a strongly typed language. This is going to bother me. It is a strongly typed language, so we do need to be aware of what data types there are and which ones we're working with. The main ones that we have here are strings, which is pretty much anything enclosed in some type of quotes. Numbers can be either int, whole numbers, integers, or float, real numbers, anything with decimals. We also have lists, which are sequences of information. That can be sequences of numbers, sequences of strings, sequences of numbers and strings, lists of lists, right? It just goes on and on. You can pretty much store anything in a list. We also have tuples and dictionaries, but I'm not going to get into those today. They work very similar to lists, they just have their own little peculiarities. Okay, moving on. I know we're going really quick here. It's late, I'm trying to get us all right. So we want to get, I'm used to not working with a mic, so I apologize. Okay. Cannot get used to this. So we want to get user input, right? Well, in Python, this is an incredibly complicated process that consists of all of that, right? Create a variable name, equals is our basic assignment statement. So in this case, name equals a call to the function input, and then a string, which is going to be our prompt for the user to, what we want the user to enter. So in this case, name equals input, enter your name, is going to prompt the user with enter your name and then allow them to type. The input function will wait for the user to type and press return. At that point, it'll capture whatever they type, strip off the new line, and store it in the variable. Right? Now it does store it as a string. And that's important because, as I mentioned, Python is still a strongly typed language, so when something's stored as a string, it's a string. We can't treat it as a number immediately. You know, it does differentiate between character 1, character 0, and the number 10. So if we have a string and we need it as a number, either an integer or a float or whatnot, we do have to change that. So you may be, if you're familiar with programming, you're probably familiar with the process of casting. In Python, it's ridiculously easy. Right? In Python, we have a function for each of our data types. In this case, int, float, and str for string. They take a single parameter and they return that parameter converted into whatever function you were calling. Right? So give a call to int and a value, and it'll return the integer value. Give it float, it'll return a float. String, it'll return a string. Now, it does have to be something that can actually be converted properly. If you try to convert hello world into an integer, you do get an error. Right? But it's not that bad to work with. Right? I've also included another function here, type. Type takes a parameter and returns whatever type of data that is currently is. Right? So if you're not sure if you're working with a string or a float or an integer, you can use type to check what that variable currently is. Okay. Now, creating lists. Lists are where I think Python gets particularly amazing. Right? Working with lists in Python is great. Defining a list is as easy as giving it a name and assigning it a range of values enclosed in our little square brackets here. Right? So I've created several lists here. The first one, odds, I've assigned it 1, 3, 5, 7, and 9 for the odd numbers, right? Just comma delimited. The second one is a list of strings, in this case apple, orange, pear, grapefruit. Right? But Python is not restricted to a single data type in a list. We can mix and match to our heart's content. So in the third one, I have a mixed, right? We have 1, comma apple, comma 2, comma orange, comma 3, comma pear. Right? Mixing, in this case, integers and strings. And Python will work with that, no problem. We can also do lists of lists, and that's the last one there, my odd fruits list. Is a list made up of the other lists, odds, fruits, and mixed. Right? And we're not going to go into, at least in this lecture, how we actually would work with odd fruits, the lists of lists. But if you're familiar with multidimensional arrays, it pretty much works the same way. Okay, so once we have our lists, if you are familiar with arrays, the syntax for working with lists in Python is very, very similar. For instance, we could just do a line like print the first fruit is, and then comma, fruits, and then 0 in our square brackets. Right? Like many other languages, when we're talking about positions in the list, we do start counting from 0, not from 1. So if we want to reference the first item, it is position 0, fruits 0, not fruits 1. And it'll go up to the number of items in the list minus 1. Right? We can also assign elements or change values in our list this way. Right? So the second statement there, fruits 0 equals watermelon, just is going to change the value of apple to watermelon. Right? Simple as that. The last statement I included here, we could go into in a lot more detail. I just want to put it out there so you're aware of it, because it's, in my opinion, a very powerful little tool. And that's working with ranges in Python lists. Right? In this case, I have print fruits, and then for my position, I have 1:3. In this case, this is going to start printing at position 1 and print up to, but not including position 3, which is a little weird to get used to. Right, so this particular line would print orange and pear, which are positions 1 and 2 in our fruits list, but then cut off right before grapefruit. Okay. And you can do a whole lot with ranges. So it's good to know they exist. They're a little weird to work with, and we could spend a lot more time talking about them, but again, time. Right? So I just want to make sure you're aware of those because they can be very useful. Okay. Whew. So those.
I had a quick question about
the
range.
Yeah.
So if you want to access all the, all the numbers or all the fruits, you would have to go to 4, or in this case 5, to keep grapefruits in.
Actually, you can. Kind of a peculiarity with lists, if you want to start at the beginning or end at the end, just don't put anything there. Right? So just a colon with nothing on the end. Like if you did 1 colon and then nothing, just the closing bracket, you would get from position 1 to the end of the list. Right? You can also put in negative numbers to do like up to 5 positions from the end and stuff like that. So Pythons are pretty, or the ranges are pretty powerful. Just takes some getting used to. Yeah.
Can you print backwards? Like go from grapefruits.
I don't know if Python 3 has a way to do it in a range, but it's easy to do with lists, with a function. Yeah. Right. I want to say there is a way with ranges, but I haven't tried to do that lately, so I'm gonna. Now you got me wondering. Okay. Okay. So there are a bunch of other functions that we can work with lists. This is just a kind of sampling of them. Fruits.append will add a new, or the append function will add a new element to the end of our list. Fruits.extend works the same way. It appends to the end, except instead of a single element, you can give it another list, and it will essentially concatenate the new list to the end of the old list. Okay. Fruits.insert takes 2 parameters, an integer that's a position that you want to insert before, and then the second one is the element that you want to insert. So in my example here, insert 0, avocado is going to insert avocado before position 0, which will be at the beginning of the list. Right? And everything is automatically shifted to accommodate. And then the next one, because nothing I ever create should have an avocado in it, not an avocado fan, we have fruits.remove. We give it a value, avocado, and it's going to search through the list for the first occurrence of that value, and then remove that position. And again, everything will shift to automatically accommodate. We're not going to leave empty spaces in our list. And again, that is just the first occurrence, right? If there's more occurrences, you'll have to do it again. We have fruits.sort, which is going to sort our list. In the case of strings here, it'll sort them in alphabetical order, right? There is fruits.reverse. We'll take a list and reverse it automatically. There's several others that are there that I just haven't included here.
Print.
Hmm?
Say that hence your print.
And then the last one here, len for length, not restricted just to lists. You can also use it for things like strings, but it's going to return the number of elements in the list. Right? So if you need to know the size of the list, length fruits or len fruits there will give you that. Right? Okay. So that's working with lists. Very, very easy to work with compared to lists in a lot of other languages, right? They get even better when we get to looping. Okay. Yeah.
You said this one wasn't very Python wasn't very efficient with runtimes. I was just wondering what the default runtimes were for like the
Because
sort.
he's sending interpreter, that's why.
Or the
If you're crunching a lot of numbers, Python is slower, right? If you can find benchmarks comparing like Python operations to C++ and stuff like that, and generally Python is running significantly slower than the compiled C++ code. Personally, I have never done anything in Python that I noticed any significant slowdown. Right? I did my entire thesis in Python, and the only thing that took any amount of time to run was when I had to make a call to a Java program. Right? So, yeah, I've never personally had any issues with the speed of Python. Right? It's really just a matter of interpreted languages. Dynamically typed languages are always going to run slower. and statically typed and compiled languages. And if that's an issue, if every second counts, then you probably shouldn't be considering interpreted languages in general, right? Let alone Python. But yeah, like I said, I've personally never had an issue with it. But you could probably put together some really simple benchmarks, just printing out all the numbers from 1 to 1,000,000 and just see how long it takes, something like that, if you were really curious. Okay. So, arithmetic in Python, we have 7 basic operators for arithmetic. Most of them you're probably familiar with. Addition, the plus sign, works just like you would expect it to. Additionally, the plus sign can be used to concatenate either strings or lists, right? If we wanted to add fruits and odds together, we could just do fruits plus odds, right? And that's going to work just fine. Subtraction and multiplication work just like you would expect. Division is a little bit different from some other languages. Integer division in Python, the developers decided that accuracy and consistency of the data was more important than maintaining the data type. And so integer division is actually still going to return float, right? 10 divided by 3, despite both being integers, is still going to return 3.333, et cetera, right? If you absolutely have to have traditional integer division, where we ignore the decimal component, we have floored division, which is 2 slashes, 2 division signs, and that's going to return just the quotient with no decimal component, right? That's the floored division. We have modulus, which if you're familiar with programming, you're probably familiar with modulus. If this is completely new to you, you've probably never seen that before. Modulus, without going into too much detail, modulus is going to return the remainder of integer division, right? So in the case of 10 divided by 3, we're left with 1 left over, and so 10 mod 3 is going to be 1, right? 11 mod 3 would be 2 because we have 2 left over, right? So that's modulus. And then finally, 2 multiplication, 2 asterisks, is the operator for exponentials, right? So we can very easily do powers. 10 times 2 is 10 to the second, or 100, right? So we've got these 7 basic operators that allow us to do most of what we need to do. There are, of course, also functions for square roots and all kinds of other things that you would need. These are just the basic operators.
Does floored division mean it just rounds down?
It always rounds down. Yeah.
Even if it's 3.7?
Mm-hmm. Yeah. It works just like traditional integer division in like C++ or something, where it doesn't matter what, it could be 2.999, it's going to cut down to 2. Yeah, it just truncates the decimal. Okay. In addition to the arithmetic operators, we also have comparisons and logical operators. These you're probably familiar with if you've programmed at all before. The 6 basic comparisons are 2 equal signs is equals, exclamation point equals is not equals. We have greater than and equal, less than or equal, for doing comparisons between values. Right? In addition to that, we have the logical and, or, and not. Unlike some other languages, in Python, and, or, and not are their own operators. You just type and, or not. Right? Additionally, there's a couple of other comparisons here. Well, there's a few others. The 2 that I'm going to mention, because they are incredibly useful with lists, and when we get to loops and if statements, we'll look at a little bit better. But there are another one, in and not in, will check for membership in a list. Right? So you can do if apples in fruits, and that's going to work just fine. Or if apples not in fruits. Right? So in and not in, not included here. I do mention them when we get to the ifs and loops. Okay, so with all those operators in mind, we can get to the more meaty parts of the language and actually start making some decisions. Right? So decision making in Python, we have ifs, else, and elifs for our else-if conditions. Right? If statements in Python are just the keyword if, and then what are our condition? No parentheses, no nothing fancy, right? Just if and our condition, in this case, age less than 21, right? At the end of our condition, we do have a colon. The colon indicates that we are starting a new block of code. Most IDEs, when you press return after that point, will automatically indent 1 level for you so that you're at the appropriate indentation for the new block of code. There are no curly braces. There are no other indication of this is a block of code, right? The entirety of your block of code is indicated by that level of indentation, right? So as soon as you back out and have something back at the first level of indentation, that block of code is ended, right? So in this case, age less than 21, our only statement, if that were true, is to print too young to drink, sorry, right? The next statement that we have is elif, that's else if the original statement weren't true, we switch to the else condition, and then we check the second if, so elif, else if. All right, we have our second condition, another colon, another block of code, and then finally the last else is just our trailing default if nothing else is true, right? Python does do short circuit evaluation, right? So if the original if statement is true, it doesn't bother comparing anything else because it already has its answer. Okay. So if you're not familiar with if, else, sorry, that probably doesn't make any sense, but that's that fundamentals bit that I talked about. Okay. Yeah, and so again, just to stress it again, the colon indicates the beginning of a new block, and then after that, it's all just based on indentation, right? Okay. A few other things we can do with conditions. We can have complex conditions using those logical operators and or and not, like in the top one here, if age is greater than or equal to 0 and age is less than 18, right? Logical and states if both of those things are true, then we're going to be true, and we'll print a kid in this case. Python also, unlike some other languages, and this is one of the things I really like about it, allows us to do ranges like that as inequalities. Right? So in my second one here, if 18 is less than or equal to age and age is less than 21, then that's true. Right? And Python is fine with inequalities. You can go any which way with them. Right? Which is incredibly useful for doing ranges like this. And then finally, I do an example of the not in and not in down at the bottom here. Right? We have our fruits list again, and then if strawberry is not in fruits, we can append strawberries, right? And so checking for membership in a list is that simple, right? Coincidentally, strings are handled pretty much just like lists, so you can check for like letter membership in a list, string and stuff too. Okay. So far so good? Any questions? Have I lost you? Okay. Okay. Looping then. There are two basic approaches to loops. We have for loops and we also have while loops, pretty standard. For loops in Python are just about my favorite thing. There's a couple different ways we can work with them. We can do things like for x in range 0 to 10, right? In this case, I didn't color code this slide, I just realized that. So in this case, x, we don't have to we don't have to declare variables beforehand, so we can just name x and it's just going to work for us. Right? For x in range, and we give it a range. In this case, we start at 0, we end before 10. So 0 to 10 is going to run 0 through 9 and then stop when it gets to 10. Right? So in this case, print x. This is going to print the number 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and then stop. Right? And in this case, because of the end, it's just going to do it all in one line. Okay. So that's the basic way for working with loops. Just give it a range. Yeah.
How long does it take to print 1, 2, 3, 4, 5, all the way to 10?
To 9? Like instantaneous. Yeah, you're not going to notice.
If you get like a number like a million, if you get like a number like 100,000 or a million,
if you did that long, it would take a long time, but it takes a long time to do that in pretty much any language. Right? If you were really curious about the speeds, you could do it in
real time. Printing in real time.
Yeah, I mean, you would see them scrolling by pretty quick, but yeah, it's going to take a while. Right? It's printing anything is significantly slower than just doing the calculations behind the scenes. Right? So that's. Right. If we have time at the end, if you want to, we'll do it and we'll see what happens and see how long it takes. Right? Since there's been a couple questions about that. Okay. Another, personally, my favorite thing about loops, for loops in Python, is that it makes it ridiculously easy to iterate through a list. All we have to do is something like in our second example here, for x in fruits, print x. That's going to iterate through our entire list and print out all of our values. Right? Simple as that. It makes
Simple.
Yeah, it makes working with lists so nice. We can also specify our own list at this point, so we can do something like for x in 2, 4, 6, 8, 10, and x is going to take the values 2, 4, 6, 8, and 10. Right? Yeah, so for loops make working with lists an absolute breeze. If for loops aren't your thing, we also have while loops, and I made this example a little bit more complicated just so the people with a little bit more experience can enjoy random numbers in Python. So if we want to work with whiles, in this case, we give the while keyword, give our condition. In this case, I generate a random number and I make sure that it's not 0, right? And as long as that's not 0, I print the number that I generated and then I generate a new number for it, right? Just for the record, that's a random number in Python. Import random, random number, rand range. Okay. Simple as that. Okay. So yeah, while loops work pretty similar to how we've seen them in other languages, right? Just make sure that you do have some kind of update statement so your condition eventually ends. That's kind of the key. Okay. Okay. So now the fun stuff. Functions. Again, working with functions in Python is crazy easy. We start with the keyword def for define. We give it a name. We give it a parameter list in parentheses, which in this case I gave it no parameters, and then a colon to indicate the start of a new block of code, and then our whatever statements we want in that function. Right. So in this case, welcome to code RGB, a new line, and building better nodes. Right. Just a little welcome message that we can use. Function calls then are just the name and the parameter list. Right. I just realized that's a wall and not a screen. Okay. We can, of course, also use parameters, right? So here we have another function, def add num, first and second. Again, Python doesn't really care about the data types of variables, so all we have to do is give it the names. It'll figure out the data types. Now, the way you're using it has to be sensible. You can't, depending what you're trying to do with it, it may or may not work. But the parameters, it doesn't care what you're passing it, as long as it's capable of dealing with them. So in this case, add num first and second. We calculate the sum num equals first and second. And in this case, sometimes you do want to return values. So just return and whatever you want to return, right? So this is a function with parameters and a returning value. And so examples of how to use it, my sum equals add num 10.5, print add num 14.6, right? These are going to call the function, add the two, get the value back, and then either assign it to my sum or print it out or whatnot, right? So yeah, identifying functions, very, very simple, and compared to a lot of other languages, no mess really, which I appreciate. Okay. Whew. Now the last kind of important thing, I guess. Yeah. The last thing you need. I pretty much crammed my computer science 1 semester into 45 minutes here, so it's all the basic building blocks. So kind of the last thing we have is reading from and writing to files. This is probably the most complicated thing we've looked at so far, but it's really not that bad at all. Create a variable, in this case f, a call to the open function, and you give it a file name. Now in this case, just file name, but if that were, data.txt or hello.py or whatever. So yeah, you open a file. We have a few different ways to read from that file. A call to f.read will read the entire file all at once. A call to f.readline reads a single line. Every successive call to read line reads the next one. Right? So you'll read the first one and then it's discarded, and then you'll read the second one and it's discarded, etc. until you step through the entire file. With for loops, we can read through the entire file just like that. For line in f, print line, and that's going to read through the entire file and print it out. Right? Yet another beautiful use of for loops in Python. We can also read a file by converting it into a list. this function call here, list f, is going to take the file, read it one line at a time, and create a list where each element in the list is a line in Python, or is a line from the file, right? So if you want to store it all in a list, once you're done working with the file, it is important to close it. Just, it's a good practice. So just a call to function, or f.close, just to wrap that up and be done with it. Right? So reading files, incredibly simple, especially with these two methods. It's very clean to work with files in Python. Okay, writing to a file is a little bit more complicated. Starts the same way. Our variable f equals a call to open. In this case, we need to give it more than just a file name. We give it a file name, and then we give it a character. In this case, the example, it's W. W is the mode for write only, right? Additionally, alternatives to W, we can use R, which is read only. We can use A, which is append. Write will overwrite anything that's there. Just if you use W, it'll overwrite anything. A will append to the end of the file if there's already something there. Yeah.
Yes, in case of, for example, if you have like a file of, I am thinking in bioinformatics file, right? And you want to insert something, but in certain sequence. There is something that you want to say, I want to write in this line or in this.
So insert at a specific point?
Yeah.
I don't cover it here, but it's
Okay,
possible
but
to
it is-
find specific points in the document. Yeah.
Okay.
Yeah.
Where you want to find this match.
So where was it? Yeah. A is for appending to a file. If you don't want to overwrite what's there, you just want to add to it. And then we also have R plus, which is read and write mode. If you don't give it a mode like I did in the first one, it defaults to read only. Right? Okay. So once you've opened your file for writing, writing is just a function call to f.write, and I accidentally made that parenthesis green, it shouldn't be. So f.write and a string. It has to print a string, right? If you want to print something else, you have to convert it to a string first. Right? Luckily, we have that str function, which can do that for us. Right? So in the second example, I want to write 14 to the file, so I do f.write str14, and that's going to convert the 14 to a string and then write the string to our file. Right? And of course, don't forget to f.close to make sure our file is closed. That it's especially important with write because it tends to want that closed before you can really see some of the changes sometimes. Okay. So okay, so that's writing to a file. And that's pretty much all the basics. I'm not going into classes. Python will do object-oriented programming, but I figured that was a little bit ambitious for 45 minutes. So that's the end of the show. Although if you were curious, if you paid attention to the comic on the first screen while I had it up, and it joked about import anti-gravity, the developers of Python have a sense of humor. Yeah, they went ahead and implemented it, just because why not? But, okay, so that's all the basics. There's probably lots of questions. So, I would say, no? I actually got to do that in record time. I'm impressed. Just about 45 minutes, which is what I promised. Okay. Yeah.
Why I need to learn Python? If I know another language, why I want?
The big advantage to Python is just the simplicity of the code and readability, maintainability, right? I mean, that's a very good question. If you know one language, why do you really need to know another? And, you know, the honest answer,
I remember
you don't necessarily need to,
Well,
but
for
I remember
example,
basic to the same.
well, for example, in the bioinformatics community, you have to adapt what the community is using. 5 years ago, they were using Perl for bioinformatics. Right now, I am going to, face again bioinformatics stuff, and now they changed to Python.
Python has been widely adopted by the
right now,
scientific community.
I want to learn Python, Because they are not using Perl anymore.
Hmm?
The community is using Python.
No,
That's
SciPy. I originally learned Python because Python has NLTK, the Natural Language Toolkit, right, which is all written in Python for natural language processing. So yeah, it's especially if you're working in academia, it's huge in scientific computing right now. There's so much done with it. And like I said, there's a lot of different.
Has a hook with R, right?
Hmm?
I think it has access to R as well.
Yes.
Yes. And
Yeah, there's a lot of wrappers for pretty much any other language that you need to
And
call.
another, yes, I found also that people are doing a lot of stuff in mobile applications using Python.
Yeah, definitely.
But
Really? Was it good?
yeah,
Yeah, thank you.
I got through it in record time, which surprised me. I thought I was going to go a lot longer.
All right, let's thank Lucian.
Yeah.